In October 2023, the James Webb Space Telescope pointed its infrared cameras at the Orion Nebula and found something that by every existing theory of how planets form should not have been possible. Scattered through the nebula's star-forming Trapezium Cluster were dozens of Jupiter-sized objects, not orbiting any star, not tethered to anything, drifting freely through space. That alone wasn't shocking. Free-floating rogue planets had been found before. What shocked astronomers was that roughly 40 of these objects weren't alone. They were paired up, orbiting each other, drifting through the nebula as bound couples, with no host star anywhere nearby. Astronomers named them jumbos, Jupiter mass binary objects. And the problem is straightforward. There is no established theory of star or planet formation that predicts free-floating planetary pairs like this should exist in these numbers. They're too small to be stars, too isolated to have formed the normal way, and too numerous to easily dismiss as a fluke. 2 years later, the story took another turn. A new study suggesting some of these strange objects might not even be what astronomers thought they were in the first place. This is Deep Space Declassified. New classified file every week. Subscribe before we go further. Let's get into it. The discovery came from a deep survey of the Orion Nebula's Trapezium Cluster, a dense star-forming region roughly 1,344 light-years from Earth, led by astronomers Mark McCaughrean and Samuel Pearson, using Webb's Near-Infrared Camera, or NIRCam. The Trapezium Cluster is one of the closest and most active stellar nurseries to Earth, packed with young stars still glowing from their own formation, embedded in a rich, turbulent cloud of gas and dust. It's exactly the kind of environment astronomers expect to find newly formed planets. But Webb's unprecedented sensitivity allowed the team to detect objects far fainter and far smaller than any previous survey of the region could manage. What they found was staggering in scale. Over 500 free-floating planetary mass objects, ranging from roughly half the mass of Jupiter up to about 13 times its mass. The rough dividing line astronomers use between a large planet and a small failed star known as a brown dwarf. These objects are visible at all only because they're young, still glowing faintly from the residual heat of their own formation. Over time, they'll cool, dim, and effectively vanish from view. Free-floating planets like this had been detected in star-forming regions before, dating back over 2 decades, using ground-based infrared telescopes. What Webb found buried within this larger population was something genuinely new. Roughly 40 of the 500-plus objects weren't traveling alone. They were gravitationally bound to another Jupiter mass object, orbiting each other at extraordinary distances, in some cases up to 390 times the distance between Earth and the Sun, a separation that would place the pair's outer member far beyond even the most distant reaches of our own solar system. That pairing is what makes jumbos so difficult to explain. Planets, under every established model of planet formation, form inside a disk of gas and dust, swirling around a young star. The same basic process that built our own solar system's planets around the Sun. A planet that gets gravitationally ejected from its home system, flung out into interstellar space by a close encounter with another massive body, is a well-understood phenomenon. Astronomers have modeled and even observed evidence of this happening. But ejecting 2 planets simultaneously, in a way that leaves them still gravitationally bound to each other afterward, is a completely different problem. The physics required to eject a pair while keeping them paired, rather than scattering them independently, is, in the researchers' own words, quite unclear. It doesn't fit the ejection model cleanly, and forming 2 Jupiter mass objects independently, with no star involved at all, pushes against a separate set of assumptions about the minimum conditions required for something this size to form directly from collapsing gas. Analysis of the jumbo's physical properties deepened the mystery rather than resolving it. Spectroscopic data show these objects have temperatures around 1,300 degrees Fahrenheit, consistent with genuinely young planetary mass bodies roughly 1 million years old, the same rough age as the surrounding star-forming region itself. Their atmospheres show signatures of carbon monoxide, methane, and water vapor, an atmospheric composition broadly consistent with what astronomers would expect from a genuine gas giant planet, not a tiny failed star. That composition data helped rule out one simpler explanation, that jumbos might simply be undersized brown dwarfs, misclassified due to measurement uncertainty, rather than a genuinely new category of object. Alex Scholes of the University of St. Andrews, whose 2022 research had predicted Webb might be sensitive enough to detect low-mass rogue planets in young clusters like this one, called the results surprisingly plentiful, with a binary fraction, the proportion existing in pairs, that was, in his words, completely unexpected. The discovery didn't just add a new category of object to the astronomical catalog, it directly challenged the working assumption that planets require a parent star to form at all. With no established formation pathway that cleanly explains the discovery, researchers have proposed several competing theories, none of them fully satisfying. The first treats jumbos as scaled-down star formation, pockets of gas and dust within the nebula collapsing directly under their own gravity, the same basic process that builds stars, just on a smaller scale that tops out at planetary rather than stellar mass. Under this model, jumbo pairs would form the way binary star systems do, two collapsing cores forming close enough together to become gravitationally bound to each other from the start, never orbiting a star in the first place. The second theory keeps the ejection model but modifies it. Rather than two planets independently kicked out of their home systems and coincidentally ending up paired, some researchers propose planetary systems with two giant planets already orbiting near each other could be ejected together as a unit, preserving their mutual binding through the ejection event, rather than acquiring it afterward. Modeling by researchers Wang and Perna suggests this works best for planetary systems where the two giant planets' orbits were already close together before ejection, at distances of roughly 70 to 100 astronomical units from their star. Neither theory has been confirmed. Both remain live possibilities, competing to explain the same unusual population of objects. For nearly 2 years, jumbos stood as one of the more genuinely puzzling recent discoveries in astronomy, real, confirmed, and unexplained. Then, in 2025, a new simulation-based study introduced a twist nobody had anticipated. Some researchers now suspect jumbos might be considerably rarer than the original discovery suggested, or possibly not what they first appeared to be at all. The new research modeled how young star clusters evolve dynamically over time, tracking how gravitational interactions between densely packed young stars and planetary mass objects would naturally play out. The simulations suggested that the jumbos astronomers are currently observing represent only a tiny fraction of however many originally formed, implying either that jumbos are being destroyed or separated at a high rate as the cluster evolves, or that the observed population reflects selection effects in what Webb was actually capable of detecting, rather than the true underlying population. This doesn't erase the original discovery. The objects Webb detected are real, confirmed detections, verified by multiple independent research teams. What's being newly questioned is how representative that sample is, and whether some fraction of what's being classified as a bound jumbo pair might instead be unrelated objects that happen to appear close together from Webb's vantage point, without actually being gravitationally bound to each other at all. That distinction matters enormously for what jumbos actually tell us about planet formation. If the pairing is real and gravitationally bound in most or all cases, it represents a genuine, confirmed exception to how astronomers believed planets and planet-like objects could form. direct evidence that the universe has at least one formation pathway completely independent of stars. If a meaningful fraction of the observed pairs turn out to be optical illusions, objects that appear close together in Webb's two-dimensional images purely by chance, without any real gravitational connection between them, the population of genuinely bound jumbos shrinks, and with it, the size of the challenge they pose to existing theory. A smaller, rarer population is easier to explain as a genuine but uncommon edge case in known formation physics, rather than evidence of an entirely unrecognized process. Resolving this requires exactly the kind of follow-up observation astronomy always eventually needs: additional imaging over time, ideally combined with precise velocity measurements, to confirm which jumbo candidates are moving together as genuinely bound pairs, and which ones are simply lined up by chance from Earth's specific point of view in a crowded and complicated nebula. It's worth being clear about what hasn't changed, because the 2025 study is easy to overstate in either direction. The core discovery that Webb detected free-floating, Jupiter-mass objects in the Orion Nebula, some in apparent pairs, remains a real, confirmed, peer-reviewed result. Nobody is disputing that these objects exist or that Webb genuinely detected them. What's being actively debated is a narrower, more technical question: how many of them are genuinely paired, and what that number implies about how common or rare this formation pathway actually is across the galaxy. That's a meaningfully different kind of scientific uncertainty than does this phenomenon exist, and it's worth distinguishing the two clearly, because headlines compressing "new study questions some jumbo pairings" into "jumbos might not be real" overstate how much has actually changed. This is, in a sense, a smaller-scale echo of exactly the pattern astronomy keeps producing in the Webb era. A striking, seemingly rule-breaking result, followed by a wave of follow-up analysis that narrows, refines, or partially revises the original claim, without erasing the genuine strangeness that prompted the initial discovery in the first place. Regardless of exactly how many jumbos turn out to be genuinely bound pairs, the discovery has already reshaped how astronomers think about the lower boundary of planet formation. Before Webb's observations, the working assumption was that objects below roughly the mass of Jupiter, forming in isolation without a parent star, would be vanishingly rare, an edge case at the theoretical margins of what's physically possible, rather than something astronomers should expect to routinely find in survey data. Webb's Orion Nebula results, even under the more conservative post-2025 interpretation, suggest free-floating planetary mass objects are meaningfully more common in young star-forming regions than that assumption implied. That has real consequences beyond this one nebula. If planetary mass objects can form directly from collapsing gas, independent of any star, at a non-trivial rate, then a meaningful fraction of the galaxy's total population of planet-sized bodies may never have been part of any solar system at all, wandering interstellar space alone, or in some cases, paired with a single companion, for the entire multi-billion-year remainder of their existence. The jumbo story is also a useful case study in how astronomy actually works at the edge of what current instruments can measure. A pattern worth understanding because it applies well beyond this single discovery. A powerful new instrument comes online. It immediately finds something nobody predicted, at a level of statistical confidence that clears the bar for publication, but not necessarily the bar for full explanation. The finding generates real excitement, real headlines, and real theoretical scrambling to explain it. Then, over the following months and years, follow-up observations and more sophisticated modeling either confirm the original result at full strength, narrow it to a smaller but still genuine phenomenon, or in some cases, overturn it entirely. Jumbos currently sit in the middle category, confirmed as real, still being actively narrowed and reevaluated. That's not a failure of the science. It's what healthy, functioning science looks like when a new instrument opens up a genuinely unexplored part of the sky. Somewhere in the Orion Nebula, roughly 1,344 light-years from Earth, Dozens of Jupiter-sized objects are drifting through space in pairs, bound to each other, bound to no star, and bound by no theory of planet formation that fully explains how they got there. James Webb found them by accident, while surveying one of the closest stellar nurseries to Earth for the smallest objects its instruments could detect. What it found instead was a population of planets that, by the standard rules of how planets are supposed to form, shouldn't exist in these numbers, in these pairs, completely untethered from any star. 2 years later, astronomers are still working out exactly how many of them are real, gravitationally bound pairs, and how many might be an illusion of perspective. Either way, the discovery has already done something rarer than confirming a theory. It's revealed a gap in one, right at the edge of what our best telescope can currently see. Do you think jumbos are genuinely bound planetary pairs, or an illusion of perspective? Leave your take in the comments, and subscribe, because the next classified file goes up in a week.